What this is I'm reading through Jeremy Daly's Off by None issue number 50, and you can see up here in the top we have all these tabs. There's actually like 55 in total. And basically what we're doing is yesterday I went through and I recorded about an hour before my cough started to get too bad where I had to stop it. I had to edit the video a whole bunch to cut that out. So what I'm going to do now is I'm going to continue where I left off yesterday. We did about 4 articles or 5 articles. The goal of this is that I want to learn and I want to share that and share my thoughts on these different articles and content. Right now in the Off by None series, this one's from August 13th, but there's ones that are current and they come out every week. And Jeremy Daly is actually curating this list, so that's really nice as well. And so one of the big things with this is that as we go through these articles and we read it and we learn some stuff, in each article I'm going to pause it, I'm going to read through it, scan over the material, get an idea for it, and ideally over this first issue, it might be a little bit rough going, and so thanks for sticking with me on that. But as we get through these 50 articles, past that point, I'm assuming that I'm going to be in somewhat of a flow when I'm actually going through this. The big takeaways that I'm hoping to get out of doing this is that one, it's a challenge. It's very hard to read this many articles in a row consistently and kind of consume this information just as a person. But it's also super beneficial for my career because what I do in my day-to-day, so right now it's 6:43. I think yesterday I recorded around like 9 p.m. or something. But my 7 a.m. to like 7 p.m. type of thing usually is working as the CTO and CEO of Serverless Guru, and I'll work with clients doing serverless consulting and helping them understand how to use things like Fargate or EKS, Lambda functions, API gateway, doing lots of like infrastructure as code, automation, bash scripting, all that stuff, Node.js application development. And so what I'm hoping to get out of this is also getting a little bit more for my practice, my consulting practice, and being able to communicate with a little bit more confidence in areas that maybe I didn't even know existed. Like, for instance, yesterday in our last video, we talked about that Oracle has a new cloud functions that they've released. I actually missed that one because there's just so many. Obviously, this is just one newsletter, just 1 week, and there's 55 articles. So, each week is probably gonna have something similar to that level. So yeah. So in light of that, let's just get into it. We'll go back to the first article where we left off yesterday. After I went through a rant on serverless support and this new serverless guru offering that I helped create yesterday, which I talked about in length for probably like 10 minutes, which was completely off topic, except, I can't help it. It's like as my brain perceives things as I'm reading, I'm just going to like kind of go off the cuff and then go down that rabbit hole. So hopefully enjoy it. Let's get into it. Yeah, so this is the first article here. All right, so this is a case study by Cloud Forecast published on the Serverless blog. It's called Serverless for Startups is the SEO title there. I think we started off yesterday with talking about this $100 startup concept. That's when I ranted about Serverless Guru support because the idea behind it is that we created a landing page and then it only took like an hour to build it with a serverless API that we already had, and we just recycled it. And in that way, if anybody sends a request saying, "Hey, we're a enterprise company, we're looking to do support, or we need support for our development team," then they can fill out the form. And if they don't, it's fine. It only took us an hour to create it. If they do, that's awesome. It could be a whole different vertical of Serverless Guru. We've seen a lot of benefit doing support, but now we actually have a system that we've been building internally with different clients that have needed this. And we've kind of built up a case study almost like privately where we've supported 35, 40 developers at a billion-dollar company. And in light of that, we've been able to learn a lot of lessons about how to unblock people quickly, how to share information between teams. And I think that's really the power of serverless is that underneath the upfront things like running a Lambda function versus running a server or a container, the other things is that when you're doing it at scale and it's able to break down these silos in different teams and everyone's able to collaborate in a much more cohesive way, then you end up creating a structure where it's extremely beneficial to the company And it's extremely beneficial to everybody that works there because a lot of times, when you're in these siloed teams, especially at a big organization, you just twist like one knob, right? And that's all you do. But then when serverless comes in and now people are doing the cloud architecture as well as the backend development, and some people are even doing backend, cloud architecture, and the front end at the same time. And that's really exciting because it gives you a lot of different areas to explore, lots of professional growth, and you feel like you're making a really big impact because you are. And so I'm really fascinated by productivity efficiencies, and I've done that throughout my entire life so far. I played poker for a living for a little bit, and one thing that really fascinated me was this concept of GTO, which was like game theory optimization or optimal game theory optimal. And the idea there is that when you're playing versus another player, that other player is going to play differently, right? So if I'm a good poker player, what I'm going to do is I'm going to adjust how I play based on how the other person plays. And what that means is that I'm going to adjust based on experience level. I'm going to adjust based on how aggressive they are. Have they been drinking alcohol? Do they seem like they're upset? And based on all those different things and the type of hands that they're playing, I'll be observing all those different variables. And then based on that, I'll have my own internal strategy when I'm playing against them. And so you can take that and you can actually apply it to IT. And I think that that's a unique concept, and that's something I'm building on right now. But outside of this, behind the scenes. But basically, the idea is in these companies, there's a spectrum between a startup and like a some company that's really like a Netflix that's really crushing like let's see, they have like Chaos Monkeys and they have all this like crazy cloud architecture and services that the team's rolling out and open source things. And they do a really great job on that, similar to like Google, for instance, right? Or even Amazon. And so the cool thing though is that you can kind of see the spectrum from like, okay, we have Google on the right, and then we have some startup that's just now starting, or some older company that's just starting, and then you can see the progression as they move through from running their own stuff on premises to running things on virtual machines to then doing like a hybrid cloud to then running virtual machines only on like AWS or Google or Azure or whatever, to then moving to containers and having some servers, to then taking a tiny touch into serverless, using Lambda functions for backend processing, to then recognizing the value of it, to then doing infrastructure as code for the first time, to then moving to having everything as infrastructure as code, really getting into fully managed services, starting to chip away at their monolith using some type of pattern. And then as they continue down that process, they then get to a place where the whole team is now, there's no siloed off operations team or siloed off CI/CD team or cloud architecture team. They're now all kind of cohesively working together, and it's really cool. And you can kind of see that full spectrum. And so now with that in mind, and based on like observing these details over the past like 2.5 years, 3 years of doing this, and working with lots of different clients, doing consulting, which is my favorite part about it, is I've been able to see those same type of variables that I saw with poker, and now that's giving me some insight into basically how to help clients better, right? And I think that that's a really cool thing, which I'm hoping to build on that concept later. This isn't like a short-term thing for me, so I'm expecting that over multiple years of doing this, eventually I'll have enough that I can share it in a very clear and direct way about the type of things that I'm starting to dabble with right now. So that was a long rant. Give me 1 second to pause. All right, so now that we've kind of gone through my whole rant thing, which will probably happen multiple times, we could easily go a whole hour, and I might only read through like 2 of these articles. But this one is by man, I cannot pronounce the name, but Francois. I want to say it's Francois, but I apologize. But basically, what he's talking about here is Cloud Forecast is a company that does like predictions around spend. It sounds like based on reading some of the article. I didn't get a chance to go to the website yet, so I apologize. But basically, they talk about a couple of things. So in their goals, inspired by the $100 startup, which I'm definitely inspired by that as well. I'm not going to rant any more on that. They want to help companies save money on AWS, so that's a very noble goal. And they wanted to put it in front of clients as soon as possible to keep the excitement levels high. which is good because a lot of times when you aren't able to ship something fast enough, from idea to actually having it out there, which is the biggest benefit behind. That's one of the biggest benefits behind serverless is that you can do that so fast. Um, just look at Amplify. We talked about this in the last video, but with something like Amplify, somebody built a Evernote remake in 6 hours. They used Amplify to create the GraphQL connection, CloudFront for a CDN, S3 for the website hosting, Dynamo DB connections, and tables and all that stuff, all automatically, and it created the front end code as well. And then all they had to do was code the UI, and it was done. And it's like, that's crazy. And so that's where we're at now. They wanted spend time debugging, spending time debugging config deploy processes will not make the end product better. We are looking for an out-of-the-box solution that we can grow with and allow us to focus on our MVP right away. So I think that's really cool. All right, so I'm sure you can tell like my eyes are already starting to water a bit. I think I ranted for a bit too long, started to wear out my voice. So I'll try to keep it a little bit more calm. I won't get as passionate and worked up. I'm still recovering from being sick. So, and then the other goal that they had was cost effective. So as a startup, they wanted to avoid fixed costs by building a system that would scale seamlessly based on their client base. So that's definitely use cases for serverless. And they're not working with so much scale or any at all really when they're just starting that they don't really have to worry about like the any downsides with serverless or any like workarounds they have to do or any other things. They can just focus on strictly getting something up, and that's what's really nice about serverless is that if you want to build like a POC and you want to build something very quickly like that, you can get a whole thing up and running in a very short period of time. And it all through like experience, you end up being able to do that faster and faster. So for instance now, if I was going to build an API with 2+ years of experience doing it, it would take me like 5 minutes or less, maybe like a minute. And that's just because I know what to search, I know how to copy paste it together, I know the exact commands to run. I've done it thousands of times, so it's like I can do it asleep at this point, and so can most people. And that's what's really nice about the serverless framework, as they're talking about, is that it'll kind of grow with them. So they can start out very simple, and then they can keep building on it. So AWS Lambda plus serverless, easy, focus, cost effective. Totally agree. Focus on writing the product and let serverless manage the rest. Easy to configure and easy to deploy. Serverless supports multiple platforms. This is a really good point. There's something where people talk about like, for instance, should I use like AWS or Google Cloud or Azure? There's people that talk about multi-cloud, and there's people that say that the multi-cloud is like this, really bad like thing that people talk about, where it's not actually in reality. Pick a cloud provider and go with it. And I think like that's the big thing too, is that it's everything. Everything can be right with the right context, but for the most part, that's where that spectrum comes in, right? So if you're at a point where you're a global company and you can make these micro adjustments that end up having this huge impact, then yeah, do whatever you want, right? But if you're some small company, if you're trying to architect for a multi-cloud to prevent lock-in, you're going to end up putting yourself in a place where you're focusing too much on the nuts and bolts and not enough on like the higher level vision of like what you're actually building. And so, in my view, even though the serverless framework can support multiple platforms, which is nice because some people aren't working with AWS or working with Google, in the multi-cloud spectrum, there hasn't been a single time where I've literally had like AWS and Google Cloud things both being deployed through the serverless framework, and it was like a good experience. And that's just because like it's not so much the serverless framework, but it's just a matter of like stitching these things together. It's always going to feel a little bit like you're kind of like doing duct tape. But I think enough of that. So moving forward, the serverless framework has a lot of plugins. So this is a really big benefit of the serverless framework. I've written a lot of articles about this. I've actually wrote a plugin called like the serverless framework or serverless termination plugin. And it basically allows you to add termination protection to CloudFormation stacks when you actually deploy. And then there's multiple stages. And then somebody came after me and they built one that had like slightly better documentation and SEO, and mine kind of fell away. But kudos to that person. But it seemed like I read the article where they actually listed out their plugin, and they listed mine as inspiration for it. So at the end of the day, it was built literally for the community. So the fact that it's being used at all is good. But yeah, the plugins is super cool. One second. So the fact that anybody can create a plugin and that the whole community can contribute to it is a really big benefit of it, because Serverless Framework is open source, and that's a pretty great thing, honestly. That's a really big downside with something like the serverless application model from AWS, because although you can do similar things as the serverless framework, it is underneath the AWS umbrella, and to some degree, it feels a lot like you're just writing CloudFormation in a slightly enhanced way, but it's nowhere near like the serverless framework and extensibility and being able to have like open source contributors and extended in various different ways. So great documentation and community, 100%. Original requirements were simple, 4 Lambda functions, RDS, Dynamo DB, SQL. We used 4 functions here. So you can see that they have one function here that has a timeout of 60 seconds. They have a events schedule with a rate of 5 minutes. So this is a cron job in serverless. So if you haven't seen this before, this is like 1, 2, 3, 4, 5, 6, 7 lines, and they've created a cron job without having to go onto a EC2 instance and actually create that like cron tab file and then write out some command and do all those things. This is actually going to do this automatically using CloudWatch rule, like AWS CloudWatch rule, and they connect it directly to a Lambda function. And so these 5 lines, and then this line here, this handler, this actually connects to their, I don't know what they're using for their, whether they're using JavaScript or Python or something like that, but this connects to their, let's say, their JavaScript Lambda function, and that JavaScript Lambda function could have like 20 lines of code. And so as every 5 minutes it's then going to invoke that Lambda function, then that Lambda function is then going to run its 20 lines of code and then do something like hit a database or pull in a whole bunch of data and then send it to Cloud Forecast, and then it'll die, and you're not being billed when it turns off. So let's say that this runs every 5 minutes and it runs for like 5 seconds. That means that for 4 minutes and 55 seconds, every 5 minutes, you're not being billed. So only 5 seconds every 5 minutes. Then calculate that over, a day, a month, a year, and that's kind of your cost for that Lambda function. All right, so moving along, we also have another one down here, which is hooked up to SNS. So SNS is the notification service for AWS Lambda, for AWS for serverless in general. Basically, what it allows you to do is you can hook SNS up to other Lambda functions, and you can do what's called a fan-out pattern. And so you can have one Lambda that triggers a SNS topic, and that SNS topic could trigger 4 different Lambda functions. Or you can have an S3 bucket that then triggers a Lambda, or triggers SNS directly, and then triggers 4 Lambda functions. So why would you want to do that? Let's say that you had a video, and you needed to take that video, you needed to chop it up every like 5 seconds, you needed to change the pixel rating or something, the encoding of it. Or let's say you had images. So let's say that you have an image, you need to make it grayscale, you need to put like 4 different filters on it, maybe you're doing some machine learning, some computer vision. And in that computer vision project, you need to basically build out these different types of data for training. Well, you can have that S3 bucket, which then triggers SNS, or a Lambda function that then triggers SNS or SQS, whatever it is. And then from there, those 4 Lambda functions will fire off in parallel once it goes from SNS to the 4 Lambda functions, and they'll all get passed the image URL that goes back to S3. They'll pull that in, they'll change the background color on each one of those Lambda functions in parallel, and then save it back to the S3 bucket, which then could trigger another set of Lambda functions or SNS or SQS. And then based on that, it could do further things, like it could change the orientation of the image, it could shrink it down, depending on what the machine learning model actually requires, because some of them require very small photos. And that's kind of cool. And so what you can see here is that in this screenshot, they are using this SNS connection, and they're connecting it to this send custom report ARN, and then that's going to fire off that Lambda function. Scrolling down, they have IAM role statements. So these IAM role statements, these allow you to actually specify the permissions for the Lambda functions. And so when we're working with Serverless and Lambda and the Serverless framework, they make it really easy to do least privilege. And there's multiple different ways to do it. Out of the box with the Serverless framework, you can do IAM role statements at a global level. And so, for instance, these 4 functions with a global level IAM role statements is going to apply all these permissions to every single one of these functions. However, you can use a plugin by the community called the Serverless IAM role plugin, and that allows you to add IAM role statements under each one of these specific functions. And so in that way, maybe this send custom report, it needs access to do Dynamo DB get item, but that's it. So then you don't have to give it put item or query or any of those other ones, because it only needs to be able to do get item. And that gives you least privilege and a higher level of security. And serverless makes it really easy to do really good security. And so that's really nice. Cool. All right. So moving on down, that looks like they're using .env plugin. That allows them to pull in from a .env file, which allows them to have their environment variable set. There's other ways to do that, but probably out of context here. It said we consider running a couple of small instances to do the job, which would cost us at least 1,000. But using AWS Lambda, it costs them 0. Right? So that's pretty impressive, and that's something that you can do when you're just starting to build an idea. You don't have to think about all these other things. You don't have to spend $1,000. You can actually build out an idea and actually have traffic and real users and be paying 0. And that's really the power of serverless. In my mind, is that it's broken down the barrier for new ideas, and it allows you to focus strictly on the idea and less about other prohibiting factors which would prevent you from actually trying to build something, because you would go, I don't have $1,000, I don't have enough things to actually roll this out. And you can even see that with things like machine learning, which to run like a machine learning instance is usually very expensive. However, I've done stuff in the past where you actually can build serverless machine learning models onto Lambda with S3 and API gateway, and you can actually do things like computer vision and all that stuff and inference without having to pay for some super large instance. And you might think, oh, well, it's going to take a super long time, but the cold starts are slow. Like that's just straight up. The reason the cold starts are slow is because it has to pull down your model file, and that could take quite a long time. So that initial cold start could take like 5 minutes. Back when I was doing this, which is like a couple years ago now, the limit was 5 minutes, and so this was a very hard thing to do. Now it's 15 minutes, so it's a lot easier to do this. But you can actually have your test and dev machine learning models running on AWS Lambda, API gateway, and pretty much run these for zero amount of $0. Initial cold start slow, but on AWS they have container reuse. This is something that Google Cloud doesn't do as well on, because they'll shut down your containers randomly, and there's not like a 3 to 5 minute or 10-minute period where if you hit it with another request, it'll keep it active. So it's a big benefit of AWS is that pretty consistently stays online for at least 3 to 5 minutes. Usually it's like 10 minutes. Sometimes it goes even longer. There's some articles out there in the universe where people have done research on seeing how long it's gone, and they've seen that a container stayed up for 2 hours at one point. So basically what happens is you pull in that model file right at the beginning, then you store it on the file system underneath the /temp directory on Lambda, and then the invocation ends because basically times out, but then the next one that comes up, that's a sub-second response with computer vision, because the model's already sitting on the container. The request comes in, runs the model file, or hits the model file, and then returns back with a result. So you pass it an image, it passes it to your Python code. Python code uses the machine learning model, sends back a response, and that can happen in like sub-second. So past the cold starts is actually a pretty feasible way to do some very complex things that usually cost a lot of money, and it's very approachable now, and that barrier of entry has dropped quite a bit. So that's really cool. Cool. All right. Well, that is the end of this article. They're basically just saying that Cloud Forecast was able to grow effortlessly with AWS Lambda. And then there's some contact information if you want to get in touch with the author. And this was written by the founder of Cloud Forecast. So super cool. All right. So let me close this one out and let's move to the next one. So next up, we have Serverless with real-time communication with WebSockets. So this is probably going to be pretty interesting. It's written by Oscar here. 4-minute read. Says, disclaimer, this article is a deep dive guide to build WebSockets on serverless architecture. So I'm going to pause it here, and then we'll come back and talk through it. All right, so I've read through this a bit. Basically, what's happening in this article is that Oscar's going through and describing what it's like to build an API using what it's like to build a serverless REST API and also serverless WebSockets. So serverless using a REST API, it has 4 layers when you're actually making a request. So when the client actually makes a request to your backend, there's 4 steps. The first one is an authorization header. Then you can have out-of-the-box Cognito user pool authorizers. So if you're using Cognito user pool for your authentication, you can actually attach that as an authorizer to API Gateway, and it's really simple actually. So the only thing that you have to add is what is the header name. So you can set the header name as authorization or some other name, and then basically you can use something like Amplify to do the login, and then from there you just pass the JWT token with the authorization header, and then you make a request to your API Gateway endpoint, and then it'll automatically authenticate it. If it doesn't work, it'll throw the request away. If it does, it'll let it through. Yep. And then the next one is API Gateway executes the associated Lambda function. The Lambda function makes all the necessary requests to the database, data transformations, returns the response to API Gateway. API Gateway passes the response back to the user. So that's the normal flow, and you can see that here as well. WebSockets on serverless, more sophisticated, and yes, it's definitely more sophisticated. So what I'm going to do is, he talks about here that I'll talk about like what he's talking about here, and then we can look at the diagram, and then might keep this one a little bit more high level because, to be honest, it's a pretty deep topic, and I know it's already been like 30 plus minutes. So I want to make sure that I can like get a couple of articles in at least. So the user here is authenticated only once during the initial upgrade request. If the authentication process succeeds, then the socket connection is established for as long as any of the sides don't close it. So the user making subsequent requests to the WebSocket protocol doesn't provide his claims because his connection is stateful, and the server here, API Gateway, keeps the information about the sender. So that's kind of nice. It would basically just maintains that state on API Gateway side, and as long as that connection to the client and to your API Gateway is established and hasn't been broken, then they can keep interacting with the app, and you don't have to worry about what sounds like you don't have to worry about refresh tokens or having to as I said, you don't have to worry about refreshing the token, and that can be nice. So let's go ahead and look at this. So the first thing that happens here, let's just zoom in, is let's say you have user 1. They go to the onConnect. OnConnect will then go to goes to Amazon API Gateway WebSocket API. This WebSocket API is going to use a custom authorizer, which is a Lambda function. The Lambda function will have, let's just say, 20 lines of code. The 20 lines of code will go to Cognito. Cognito return back what's called an RSA signing key. And then from there, that will then come back to the actual client. The client will then pass that forward to the onConnect function. So when it goes to the WebSocket API, it has a custom authorizer, which is a Lambda function. That custom authorizer is going to go to Cognito and then come back to API Gateway. And then if that passes, it'll then go API Gateway directly to the onConnect. That's one request. It's not going back to the client and then back to the Lambda function. It actually stays within API Gateway. And then it goes to the onConnect function, which will then access the database and do these different details. And then once that connection is established, you can see here the second one is at connections. and you can see that they're actually able to keep interacting with. So like one of these is a notify team function. That one's able to go to the notify team function and respond back. I think I'm doing that in a backwards manner. So let's jump down here. So user 2. So now we've established a connection up here in this top part. And now they're going to make another request, right? So this time they're going to go to Amazon API Gateway REST API. So they're just going to a REST API endpoint called votings and then /vote. And so this user is trying to vote for something. He's voting for his team. He votes. It goes to the voting lambda. That voting lambda will then trigger SNS, and we talked about that earlier. That's the notification service. And the notification service, SNS, can hook up to another Lambda function, and that's what you see happen here. So it basically stores the vote inside of Dynamo DB. That way there's a state being maintained. And then it'll go to the SNS topic, which then invokes the notify team function. And then that then returns back to the add connections and then updates all 3 team members. So now all 3 team members get a notification that somebody just voted. And that's how this flow is working, and this is happening in real-time communication, and it's using what Oscar has described here. So let me go back. So as he's saying here, there's no out-of-the-box integration with Cognito User Pool. So above, we had this cool thing where we could just use API Gateway. We could use this authorization header and a Cognito User Pool authorizer. But we can't do that with this other model with the Websockets API. And so in that way, you have to use a custom authorizer, which is using a Lambda function. And that Lambda function then returns back the public RSA key and then later grants the access by setting an IAM policy in response. That IAM policy will then grant the Lambda function that comes afterwards to either be able to invoke it or to fail the request. Let's see here. In the above architecture, there's a socket ID. It's saved both in the connections table and the profiles table. So that's kind of interesting. I think I missed that when I looked at it. Yeah, connections table here and profiles table. And so they're keeping track of the socket ID. The authorizer is executed only once. We talked about that. This makes the subsequent request to socket even faster because it's already done the authentication, so it doesn't have to redo that flow. It could just make normal requests to the API endpoints. And they say that they are sending a so they say that they're sending a post request to the API Gateway's add connections route with the ID of a socket we want to notify in the path. And they said if we want to notify 100 sockets, we have to send 100 post requests. But so far, it's worked well in production. So you might have limited runway with that, depending on how big of scale your application actually is. And then past that point, let's see. Each request to the API Gateway WebSocket API must be signed. This is to ensure API Gateway has permission to push the data to the user through the socket. Used to require a lot of steps, but thanks to a recently, so he actually created a package called the AWS Request Signer. You can do it with pretty much no effort. So if you're interested in doing WebSockets API similar to what's being shown in this article, there's actually what looks to be an NPM package for it. So that's nice. Yeah. So also, Oscar kind of mentions down here that if you're looking to get started with this, he says to text him, I think, somewhere. Let's see. Yeah, so he said, feel free to text me or hire my services. So you get a fully automated serverless setup with best practices within a week. So if you're interested in that, there's that. Cool. All right, so this was the WebSockets API article. So serverless with real-time communication with WebSockets. A while back, I wrote an article called, I think it was super long title. It was like serverless, or it was like real-time serverless AWS IoT MQTT something, and MQTT real-time application with React.js. I did this super deep dive 12-minute article where I built out everything with the images and all the steps, and I showed how to build the whole flow for it. and it's a lot. It takes a lot of stuff to actually do that. But I had a React website where it had a IoT, AWS IoT, which is Internet of Things, MQTT, like Q or whatever they're calling, whatever they call it, and then basically it would communicate. I would have to publish a message, and then it would communicate back to the client. And so the idea there is that if you had like 1,000 clients, and then you pushed a message, it would basically push that out to all 1,000 clients in real time. And that was a pretty cool project. You can find that on our Medium. So if you go to medium.com/serverlessguru, then you'll be able to find that article in there. Or if you just search like AWS IoT MQTT, I'm sure it'll be like one of the first results because it's very specific. Like it's a very hyper specific article. It was probably useful for like all of like 5 people, but I had a pretty good time writing it. And there was actually some people that came back and were like, hey, this was exactly what we were trying to build. So hit the target. Cool. Okay, so let's close this one down, and it looks like this one cannot be seen. So RIP, it looks like potentially it's missing a slash here. Could it be that simple? Yes. Yes, it is. That's how you know I'm a developer right there, because I saw the missing slash and I added it, and that's why I get paid the big bucks right there. Okay, so moving forward, some examples from microservices you can extract to serverless functions. Microservices you can extract to serverless functions. Okay, sweet. It's by Philip. So it looks like, based on the scroll bar, it looks like this is a somewhat deep thing. So I'm going to go ahead and pause it. I'll scan through the article, come back, we can talk about it, and we'll go from there. All right, so I've scanned through this article. Some cool things to point out here is that Philip's kind of talking about, like, these are just some examples about using microservices, or microservices that exist currently that you may already have at your company, where you can actually move those to serverless functions. And so just jumping down, what microservices could you turn serverless? Creating assets on the fly. So for instance, we talked about this earlier with the images where we were adding a filter background to it. That's one use case there. Something else that he's talking about here is the QR codes or any procedurally generated image. So for instance, I think I did something a while back where I had to generate like a barcode. And so using Python code, I was able to generate a barcode image, and then that barcode image was able to be scanned. So that was cool. And you can do that with serverless pretty easily. And then you can store it in S3, somebody can get the URL to it, and then they can print it out, all that cool stuff. Webhooks that queue events and data jobs. So let's see. So he's kind of talking through an example here. Like, imagine that your webhook starts to time out because your application can't keep up anymore. There's 3 ways to approach the problem. Extract the putting of the incoming events into a queue, outsource the heavy workload, processing the queue into a function, and then do both. And we ran into this problem as well in the past. We had some huge video that we had to basically process. And then what would end up happening is that we had like 30 gigs of this video. That was like, each video was like 1 minute, or I think it was like 1 minute or 3 minutes long, something like that. And then what it would do is that every like 5 seconds, it would use like FFmpeg, I want to say, and it would chop that video up every like 5 seconds. And then it would put it into like an S3 bucket, and then that S3 bucket would then trigger something else. And there's a concurrency limit with Lambda. And that's kind of what he gets into here, where in theory, 1,000 lambdas running all at the same time, that's a lot, right? But as he points out here, if your function runs for 100 milliseconds, that means you can process 1,000, excuse me, 1,000 times 1,000 divided by 100 milliseconds, and that's 10,000 events in 1 second. So that seems like a lot, but if this is taking longer than 100 milliseconds, then you get a lot less for your buck. And so in that way, you end up getting into a scenario where it was like we're trying to do 30 gigs of video upload all at once on S3, and the second that it would hit the bucket, it would trigger a Lambda function, and it was like trying to process it faster than it could get, faster than the upload happened. It was some weird behavior, and then we had to just hit the limit. We had this SQS queue that had a dead letter queue on it, and it was just being like 100,000 events, like all hitting a dead letter queue because we were just maxing out our concurrency. And so we ended up having to do like a workaround for that where we had like a polar, and we also tried to do some like more intelligent way where we weren't just like invoking a Lambda function directly, and we actually had some other process happening, like the S3 bucket would, or like the video would upload to the S3 bucket, and then once it was done, it would then trigger a Lambda function. The Lambda function would then put that into SQS, and then we had a polar that would then go every like 5 minutes or 10 minutes or however long we wanted to set it, that would then pull from SQS gradually and make sure that we found the right threshold where it wouldn't max us out on concurrency. And that worked well because we didn't need to have instant responses, so we didn't need to scale up to like 10,000 Lambda functions all of a sudden to process all this. because every video, if you think about a minute video or a 3-minute video, it's every like 5 seconds or 3 seconds. Each video upload, which was only like 200 megabytes, it triggered like 150 Lambda functions. And so if you imagine that there's like 10, excuse me. So if you imagine that there's like 10 videos in like 1 gigabyte, and each one of those is triggering 150 Lambda functions already. That's like 1,500 Lambda functions that are being triggered. And of course, if the S3 is happening in parallel, you max it out immediately. And then based on that, those things triggered other things, and we were soon like so far over the concurrency limit that it was just insane. He also talks about that if you're consistently hitting that high threshold, you can get the concurrency limit raised by AWS, but you should start to worry about costs, and this is really true. If you're consistently hitting that level of load, like that high intensity traffic, like high throughput computing, as he says here, then what you're going to want to do is use something else, right? So like you're going to have to use that non-cool thing called like a container or a server, right? And so although it's not as cool as using a Lambda function to do high throughput computing, it may be the best bet cost-wise if you need like high throughput computing and you need to do it extremely fast. Yeah. Then he talks about doing laborious async stuff. So if you're having to do anything that's like asynchronous, that can happen in the background. So here are some examples of things that you could do in the background. This is where serverless really shines, in Philip's opinion. So for instance, let's say you're going through a whole bunch of PDFs and then taking them apart. You're doing analysis of images. You're resizing images, pulling in data and building big CSV files. That's really easy to do with a Lambda function. Processing chunky CSV files, sending out batch emails, and a whole bunch of other stuff. So those are all really nice. And then it says that you can adjust your function's memory configuration, so even heavy file operations are not out of the question. So that's really cool too. And then you can abstract away dependencies that could change all the time. So it says that most companies I work with in my network are changing tools all the time, going from one bookkeeping tool to the other. CRMs, don't get me started. Those things are treated like underwear. At the end of the day, what you can do, you got to support those third-party tools. And in my book, it's better to change a small serverless project instead of your core app. So what's important to point out there is that, like, I think it's interesting because when people talk about microservices, and then you have like Lambda functions, I've heard it been tossed around before, or it's been tossed around as like, how do you describe a Lambda function? Because a lot of times, you can have servers or even containers that are microservices, and so you don't have to have like a monolith. You could have a monolith Lambda, right? Like just because it's a Lambda function doesn't mean it's a microservice or whatever. However, if you are breaking things apart at this like function level, where each Lambda function is like 100 lines of code, maybe it's a nano service, I've heard people say. And in that way, you're working at such a small scale for that function that you can actually adjust that one little knob, and it doesn't affect the rest of your stuff. So what's nice about that is that you can almost think about it like a unit test, right? So when you're writing unit tests, there's like input and there's output. You give it this request, it gives you back this response. And so if you're using these like nano services, these little tiny Lambda functions, if this Lambda function is handling, let's say, a certain part of invoicing, then what you can do is you can swap out that little tiny thing of invoicing with another third-party service without affecting the entire app. And of course, that's a benefit for microservices in general. But when you work at that like very granular level, you can get very hyper-specific with it. And what's also nice about it is that there's the cost granularity as well. And so this is something else which was called like FinOps, and this was talked about like I think like a year ago. Someone wrote a white paper or something on FinOps, and then now it's starting to pick up back up a little bit. Excuse me, the word is not FinOps, it's FinDev. Excuse me. So FinDev is basically this idea that let's take, and this is not probably a new concept at all, but in the serverless context, it has been a fairly new thing, obviously. So Lambda functions, they're so small, these little nano services, that you can actually isolate. You say, okay, for this invoicing API that handles this one part of maybe the invoicing API, it's just one part of it. For that, it cost us X. And here's the raw cost of it, and here's how much it's like making for the business. And here's the memory of it, and here's the timeout of it, and here is the CPU, and then let's tweak these and adjust them at that level, at this tiny little level, based on the usage of it. So in a monolith, you're basically taking your 100 services, and then you're making your capacity for the 100 services. For microservices, maybe that 100 becomes 10, right? And so, sorry, that one becomes 10 different things. So then in those 10, you maybe have like a grouping of 10. In each one of those 10 microservices, there's a grouping of 10 different functionality that's in there. And in that way, you still have to kind of accommodate for the lowest, the lowest, or like the most, I don't know what I'm trying to say here. So like basically in those 10 different microservices that have 10 different little pieces in it, if one of those little pieces is actually very draining on the system, you have to account for that one, not for the rest of them. So because obviously if that microservice is not set for the one that takes the longest or the one that uses the most resources, then it's not going to work. And so then once you go, okay, let's go from this monolith, this one thing with 100 things, to then 10 microservices, to then let's go to 100 things, where each little tiny piece is its own little nano thing. Then at that point, the ability to understand what things are costing money and why, and what things are the biggest drivers of like traffic, isolation of errors, being able to swap out third-party things in the background. And then there's the asterisk, which unless you're operating with a lot of experience in serverless, this is probably not the path to start with, because the complexity level is exponential. So something that a lot of people talk about in serverless is service full. We talked about that in the last video as well. Service full basically means you start out, you're super stoked, you start with one function, as Lego.com did. If you haven't seen Sheen Bristle's talk on how Lego.com moved to serverless, he talked about this as well, where they started with one single function, and that's what he recommends. And then they got that to production, and they just kind of built from there, right? And now they're doing a lot of really cool stuff. Yeah, so start with one function, gradually build your way up, but what ends up happening is that one function ends up becoming 300 functions, 500 functions, based on how big your organization is, right? So if you have 5 developers, it's not the end of the world. If you have 10, 50, what about if you have 100? What about 200 developers, right? Those AWS accounts, the concurrency limits, all the different chaos that's happening. One department may have 1,000 Lambda functions, and then you have to manage all of that, and somebody has to look. You're not looking through the AWS console at that point, right? Like you have to have a whole bunch of tooling around this, and that's why the serverless tooling market's jumped off as much as it has over the past like 3+ years. And I can already see, just from recognizing the logos here, up at the top we have Stackery's logo, which allows you to do IAC. We have Lamigo's logo, which is about monitoring tools, things like that. We've got Epsagon up here as well. We have Protego. We've got Yankui, and we have the serverless framework. So there's a few articles in this issue 50 from companies that are doing exactly that, and we even heard from Cloud Forecast a second ago. So yeah, basically just saying that like when you start off, super simple. As you scale up and you try to do the nano service thing, it sounds very attractive to people that don't know what actually the churning of the butter, the what actually goes into it right, when you're actually building it out, and all the downstream problems that take place. And that, let me circle back to the serverless guru support thing that we have, because this is a big benefit of it, is that, because we can see the different lines there, we could say, and I've talked about this in quite a bit of detail in this video actually, is like, when do you choose a container? When do you choose a server? When do you use a monolith? When do you use microservices? When do you use nano services, right? Like, how big is your team? How much risk are they willing to take? What is your culture, right? Like, how far outdated are the technologies that you're actually working with? Do you have support and buy-in to actually go down this path? Is your team willing to learn things, right? Like, all those things need to be evaluated. If those variables aren't evaluated, as we were talking about earlier, it's going to be much more difficult. And then you have to take the business value side of it, which is something that we do uniquely at Serverless Guru. I'm saying uniquely as if I have this, if I know this for a fact, but I don't. But one thing I can say about Serverless Guru is that we'll evaluate the business value of it actually, right? So this is what's kind of cool. This is what I'm learning a lot more about over the past year is the why. Why are you moving to serverless? Why this, right? Like, why do you think that serverless is going to solve your problems, right? Have you thought about it? Do you actually know the benefits of it? Do you know where your system's breaking down, right? And if you don't know those up front, you got to do more research, just straight up. Because the worst thing is like having a client that didn't fully understand what they were getting into, and then as we get started, the buy-in's not there, because then it just becomes hard for everyone, because we're trying to explain the benefits of it, and they're also trying to look at timelines and deadlines, and the idea that this is like a cultural shift as well didn't really get communicated very well, because the expectation was that this was a quick solution to something when it's definitely not. And so, speaking from experience there, we may be one of the only serverless consulting companies that will tell you, don't go serverless. So there's a note, because if your goal is to maintain your business and not flip it on its head, yeah, keep your servers running, right? Build out new features in serverless. Build out this new standard. We'll help you build a pattern for it. We'll give you a roadmap. We'll give you the support that you need. And then once you're comfortable with it, and your team's actually working within it, then you can go back later, once the context is built up over multiple months, like 3 months, 6 months, a year, and then start tackling and slowly chipping away at this other system. But there's a lot of time in between, the starting point and then getting to that point. And if it's not fully understood by both parties, there's a little bit of weird tension that builds up and friction. So yeah. All right. And that's the end of it. So yes, this is last but not least, there's weird one-off legacy integrations. So customers stuck in the last century has their weird workflow where you have to upload this one XML file to their SFTP. And of course, this is only a temporary thing, which ends up lasting for, no longer than 3 to 4 months, and their engineering team is already on version number 2 of it. Yeah. So, with that or whatever, do yourself a favor, put it in serverless quarantine and rest easy. I like that. Take your one edge case temporary XML workaround thing, throw it into a Lambda function, and then you're good to go. Cool. So great article, Philip. That was really great. It looks like you can follow the link up here, and you can actually probably has more articles that you can go through. So I would definitely recommend it. All right, and now we're moving back to Medium, and we've got building an infinitely scalable cloud host for less than $5 a month. So this is by Levi. I'm going to pause the video, and I'll come back in a second when it'll probably feel like instantly I'll be back. But I'm going to read through this, and then we can talk about it. All right, so I took a little bit longer of a break there. So if you're looking at the time in the top right corner, you may see that it's now 8:25. I think when I left off it was probably like 7:30 or something. It's been like a whole hour. Basically, I have not ate dinner yet, so I was ordering some Indian food, which will be here soon. And so right around like 8:45, I'll pause it again, grab the Indian food, come back, and probably wrap it up around then. Or I may eat and then continue going depending on how I feel. But one thing that I will say is I continued reading this article in the past hour, and I just finished reading through it. And it's really great, honestly. This is probably one of the best articles that I've seen on pricing for serverless and the real big benefits that you get when you're building an actual company and you're actually thinking about all these numbers. So, great job, Levi. This is a really great article. It's a 9-minute read, so it's going to take us a little bit of time to go through it. But yeah, let's just jump into it. So, what he's basically doing in this article is he's describing what he says here, paper napkin business model. So he's quantifying the numbers behind how many users does he need to be profitable, and then he's going to go into the infrastructure costs to support those users, and then he'll move into what is the difference between serverless and how does serverless compare to running like a virtual machine when the user counts are at that level. So what he's basically saying here is his model is freemium with pro plans at $5 a month and $60 a year. So 99% of free users, 99% of the users are going to be free, 1% will be pro, pretty standard SaaS conversion metrics. $5 a month has to pay for 100 users worth of cloud hosting cost and still be profitable. So that's not a lot of margin. So in this equation here, you have to figure out how many users do you need that are pro to support the cloud infrastructure that's running it, and how many pro users do you need to support the cloud infrastructure and the person supporting the cloud infrastructure? And that becomes a lot more tricky, right? And so a lot of times when people think about costs with different systems, they only think about the raw cost of the equipment. They don't think about the operational expense of actually running the equipment. And so I think that this article does a really good job of kind of walking through that. So let's go through it a little bit. So you can see here that in column B, he has 100 users. With one pro user, that's 1%. And then he has a $5 monthly revenue, hosting cost at $250. And then he has 1,000 users, 10 pro users, $50 revenue, $25 in hosting cost. And you can see there's $25 in profit. So for him to actually be making enough money to probably support having a full-time person, and to even support the app that has 500,000 users, he's going to need 5,000 pro users, 500,000 free users. That'll give him $25,000 in monthly revenue, $12,500 in hosting cost, with a profit of $12,500. So with that though, he says, but what if hosting costs were only 5 cents per 100 users instead of $2.50 per 100 users? It seems aggressive, but it means I could get to sustainability around 200,000 users. So you can see that here, that now he's it's 5 cents for the hosting cost, so it's $4.95 in profit. 50 cents now when he has 1,000 users, so it's almost the full $49.50. 10,495 only cost him $500. It only cost him $5 a month to support 10,000 users. 50,000 only cost him $25 a month to support 50,000 users. Right? This is really exciting. 100,000 users, $50 a month, and 250,000 users, $125 a month in cost. So pretty much all the revenue at that point is all profit at that point. And because there's less operations happening, and generally you have to manage yourself because it's all fully managed services, you don't have to worry about hiring somebody to actually maintain all this stuff. So this is like a real take home here, this 12,300. Okay, so let's keep going down, and then he says, so which cloud? He's talking about, Azure, Google Cloud, AWS. His pick is AWS. My pick would also be AWS if I was working with Serverless. It's a much more mature product offering, a lot more integrations, a lot better IAC, infrastructure as code, kind of build these like the way that I like to think about infrastructure as code is like it's a recipe, and you're basically saying like I want to make spaghetti, and so to make spaghetti, you have this like sheet of paper, and then you write down all the ingredients, and then you give that piece of paper to a chef or some robotic chef, and then it gives you back a bowl of spaghetti, right? So it's repeatable, so you can keep giving it the same piece of paper. It's going to keep giving you back the same exact spaghetti that you asked for. Problem with that is that if you're the one that's controlling the inputs into the robotic machine and it's then giving you back the spaghetti, obviously you want to make sure you get the ingredients right. Not the best joke, but for someone like me who can't really cook, that's why I'm ordering food. Yeah, it makes a lot of sense. Okay, so moving forward, web application costs. So this is a really cool thing because he's going to start breaking down what the EC2 instance cost of running a API web app is. So if you want to host an API web application, you're going to need a couple of EC2 instances with load balancing, and as he says, that's a pretty standard setup, and it is. And so down here you can see that he has 2 web application servers. They're Linux T3 mediums, on demand, and they cost $30 a month. So one thing to point out here is that it's not taking into consideration, it says like on demand here. It could be spot instances, but then you get into this whole thing where like this is just an idea. It hasn't been proven out. Do you really want to sign a contract for a long period of time? I would say no. So on demand is probably the best bet, even though you're paying a little bit higher cost. So then scrolling down a little bit more. So with this model, we already have a problem. The cost for the web application hosting is $61 a month. So already at $61 a month, that means that he needs 13 pro users and 1,300 free users before it's breaking even. Way above the 5 cents per 100 user holy grail. So scrolling down a little bit more. So based on this, he's going to have to, so there's another problem. He's going to have to manually scale the infrastructure up as the service scales. And he's going to have to monitor response time, CPU usage, latency, and all that requires money, and it requires hiring somebody, and it requires attention. So the solution there, serverless. So what happens if he builds everything with Lambda and API Gateway? With Lambda, you don't have to worry about the server. That's a good thing. You need to know how much memory an API request is going to take and how long it should run. But those are like 2 little dials. All the requests are only doing things like DB lookups and responding back to the client. So you can even make that even easier. You use something like AppSync and Dynamo Db resolvers or mapping templates. Mapping templates, resolvers, and a Dynamo Db data source and AWS AppSync. I'm pretty sure that Amplify will do this very easily. But you can actually completely remove your backend. You have no API gateway. You have no Lambda. So you're not paying for Lambda cost, and you're not paying for the API gateway cost because it's going to AppSync instead, and there's no Lambda function executing and running. There's no code because you're not debugging. Like, you don't have to debug anything, so there's no downstream effects from there, and you don't have to worry about the memory usage or how much the timeout is. All that's handled automatically like magic by AWS AppSync. And so in this case, if you went with AWS AppSync versus doing it what's described in this article, it would be even more savings. So that's really cool. All right, and then moving forward, so he says, let's say each user will update their website 200 times every month. That seems like a lot, but he wants to give an aggressive number, so it's a little bit more, a little bit bigger numbers to work with. So that means that 100 users will invoke 20,000 Lambdas every month. Lambda charges 20 cents per 1 million invocations. That means 100 users will cost, fraction of a cent per month. But he also wants to use API Gateway, and so API Gateway is a little bit more expensive. They came out with the HTTP API Gateway, or API Gateway v2 as people call it, and that one is like 50% cheaper or 70% cheaper, and it's faster. Basically, it has less dials to turn, so you can't do as many things as you can with API Gateway. But if you're just building a very simple REST API that's going to go to the database and come back, use AWS AppSync. Otherwise, if you want to use API Gateway, use the HTTP API, which is this new one that just came out. This article was written back in August or before, and that's the issue that we're currently on is Jeremy Daly's Off by None issue 50. and that one's not like from a month ago. That's like 7 months ago. So these you're going to be able to see some difference here in the cost calculations. So here it says it would cost 7 cents a month. That could be 3 cents a month. So just whatever this says, you could probably cut it in half, and that's going to be a little bit more accurate. Okay, so another benefit of it obviously is it scales to meet the demand. Nobody's using it. You're not paying anything. That's the benefit of this setup. So the kind of high level point down here is that web application total cost per 100 users after 25,000 users is 7 cents. So you're almost getting to a penny at that point per month. So basically, this is a really good point to point out as well. The first time that he's going to actually have to pay for anything is when he hits 25,000 users. So before 25,000 users, it's free to actually have this whole infrastructure running his application. Past that point, then he's going to have to pay for something. And then we get into database costs. So databases are always going to be one of the most expensive parts of your application. So I'm just going to skip down here. With something like a relational database with MySQL or Postgres, if he's going to do a DB T3 medium, that seems small, but maybe it will work for my needs. And this is another problem with it, is that if you're going with the server approach, you're going to have to keep scaling it up manually. You can do auto scaling. You can do multi-availability zone, RDS, things like that, with relational database service from AWS. But there's going to be more things that you have to configure and more operational overhead, and that's why the cost is going to be higher. So on paper, though, the cost of running this relational database is going to be $60 a month. So he's saying that there's no free tier on this one. So he's going to have to get to 120,000 users before that becomes profitable. So with the percentage of pro users, he's going to need 120,000 free users with 1% paid users to then be able to make this back and be profitable. So, and based on his experience with MySQL, serious doubts that tiny instance is going to scale to 120,000 users. And that's kind of the problem there, is that this database is not going to scale to a point where he actually can get to profitability, in which case he's going to be constantly losing money all the way up until he hits some huge user count. Then you have NoSQL with MongoDB. So AWS came out with a service called Document DB, and I wrote a series of articles on Document DB a while back. It kind of goes through the pricing model, and it goes through how to set it up and configure it, how to build an SSH tunnel, and all that stuff. And so you can read that on medium.com/serverlessguru, or just search for like serverless guru document DB, and you'll find the articles there. Basically, the cheapest instance for document DB, which seems crazy, is, and just to give it kind of high level, document DB is a fully managed MongoDB on AWS. So it's AWS document DB. And the cheapest instance is like $250 a month, and that's what he's pointing out as well. And there's no free tier. So, and from what I saw, like working for a client, they tried to keep scaling up Document DB over and over again. They had they had application code problems where they had some really inefficient code that would all run at the exact same time, and they had these cron jobs which would scan some ungodly millions of records of something and then put it back into the database. There was no like intelligent, like only these things changed. It was just like this really very dumb system that would just go like put it all into the take it from here and then put it into the database, and it would do that like every couple of hours or something. And so there's other problems happening there, but they had to keep scaling that thing up and then document DB. And so even at this 250 per month thing, it didn't hit their needs. It kept like the database would just crash. And so it got all the way to the point where they were paying like, they were trying to do this with like $1,000 a month or something, or $1,500 a month in database cost for a single database, because of inefficient code, obviously. But that was what they were trying to do, to just compensate to hit what they were able to hit that just running a server locally on premises for like $5 or something. $5 a month was like their overhead for like running the server on premises, but they didn't hit any issues with it. And so there's some weird stuff happening there. One second. But yeah, I think that's a big thing to point out is that even though this like smallest instance is like $245 a month, uh, he says that he has to hit 50,000 users before he's even breaking even on the database bill alone. Not even think about the web application or anything else. He'd have to get to 1 million users before this became profitable enough to run the margins that I want, run at the margins that he wants. So in a situation like that, no, it doesn't make sense. Like that you have to hit 1 million users on your app before it's profitable. That's some Silicon Valley, trying to let's make $1 billion company, uh, like the pump and dump. If you're familiar with stock trading and or if you're familiar with day trading stocks under $10, where people will pump and dump the stocks, or if you're familiar with cryptocurrency, for instance, um, that's not a good place to be in. All right, so moving past that, let's look at DynamoDB. So DynamoDB has two knobs, or it used to at least. One was for read capacity and one was for write capacity. Now DynamoDB has something which is called request, like pay per request. So pay per request is actually really nice. So with pay per request, it might actually even be even cheaper than what he's showing here. But let's just go through this. So he's saying that he's thinking that he's going to have 20% write, 80% read, 20,000 requests per 100 users. Requests would cost 5 cents. So 5-cent writes and a fraction of a cent for reads. And so that's pretty nice. The data I'll be storing is really small, even at scale, so don't anticipate going over 25 gigabyte free tier. So there's a free tier with DynamoDB, not with RDS or with DocumentDB. Backups, same thing. And so database total cost here for 100 users is going to be 5 cents. And so that's really nice. 5 cents for 100 users is really, really nice because for the DocumentDB example, that 100 users is going to cost $245 a month. And for the database, that's going to cost $6 a month. They have came out with Serverless Aurora, which is a serverless Aurora, which is an RDS offering. They have MySQL and Postgres support now. So you can actually run a serverless relational database on AWS, and it'll actually turn off automatically if you're not getting a request, and you can actually set that. So you can say, after 5 minutes, turn off, and that's pretty cool. So if you're a bigger company and you're working with MySQL or Postgres, or if you're just getting started and you already know MySQL or Postgres, and you're building something a little bit more complex than just doing CRUD functionality, which can be somewhat inefficient, then you can use something like Serverless Aurora, and you're going to get something less than $60 a month on that bill, because if nobody's using it, you're not going to get billed for it. All right, then we have file hosting here. So for file hosting, he says here, if someone hosts a web page with an embedded video and that web page goes to the front of Hacker News and gets 200,000 visits in a single day, I need to be very careful how I structure the free and pro tiers so I don't get killed with bandwidth and storage. So here's what I'm thinking. Free users, 100 megabytes of total storage and 100 megabytes transfer a month. Pro users, 1 gigabyte of total storage, 10 gigabytes of transfer per month. So he's building a static web host, not a media service. And he says for block storage, he'll use S3. For the CDN, he'll use CloudFront. And he said, I'll limit the CloudFront CDN to US and EU pricing just to make things simpler. So here's the breakdown on that. And then he says that I won't even start getting over the free tier until I break 5,000 users. And that's amazing. So data storage and transfer costs per 100 users, $1. All right, so wrapping things up, there's a few points here. I'll just recap on these two. So for the first example, it would be $306 a month to just start, right? So that's the database, that's your web app, that's your file hosting, your CDN, all that stuff. So he says that he'll need to hit 6,000 users before he starts to break even, right? So until he hits 6,000 users, he's losing money with this approach. About 300,000 users before he starts making a healthy profit. But I would need to increase my infrastructure to accommodate, and it's likely that at 300,000 users, I would be running a $5,000 a month infrastructure bill for my EC2 instances and database hosting, giving me a $10,000 profit margin. That's not bad, but it's barely enough for a full-time employee, and this system definitely needs kind of full-time maintenance, right, to continue to grow and scale. And then you have the other approach. So we went from $306 a month to start, and that's a lot. Like that for somebody that's just now starting to play around with an idea. The idea that you would have to shell out $300 a month, that's you need a lot of confidence in what you're building to do that. And then you have a dollar. I'll be right back. All right, so I got my curry. I got some chicken tikka masala and some vegetable samosas. So I'm about to chow down in a minute. But let's finish off this article real quick, and then we can decide if we want to call it a wrap. In this, $1.40 per month to start, automated scaling, zero server maintenance, instant profitability, even with a small amount of users. And if he gets 300,000 users, he'll be able to host them and make $13,800 in profit. The best part is that this would automatically scale up to meet the demand, allowing for investment in the product instead of investing scaling the infrastructure. And that's a really big point, is that serverless is allowing him to put all the money back into the product to make the product better, so then get more users, then get more profits, then put it back into instead of worrying about the server cost and the scaling cost and the database cost. All that stuff is happening in the background. You're using a fraction of it. You're being billed at a fraction of it, and it's extremely efficient. And so the final hosting cost per 100 users is $1 a month, and the profit is $3 a month. So he's now profitable immediately, and he says that looks very sustainable, and it does look pretty sustainable, right? But his recommendation here is to, go cheap when starting out, build a business that automatically scales with your success, and doesn't punish your wallet for early experiments. And I've really loved that about serverless. I've gone down a path, as I'm sure y'all can imagine, just doing a whole bunch of different business ideas and just playing around with them and creating something. And some of them are still around, but they've been running consistently for the past 2-3 years. I think I have a couple of chatbots actually on Facebook where one of them, you can take a photo, it'll actually translate the photo into words and then translate it into Japanese or Thai or Spanish from English, and it has a whole conversation flow with you. And that has been free, pretty much. So not enough for me to notice, which is probably less than $5 a month over 3 years. Sweet. So that wraps up Levi's article here about building an infinitely scalable cloud host for less than $5 a month. Fantastic article. I actually shared this, Levi, with my team. When I paused the video at one point, I shared it with my team. And I think that they're going to find this really great, because it really captures the business value of serverless in a really, in a very clear numbers way. And that really speaks to upper management and business executives and things like that. So great work. All right, and then the next article is how to schedule any task with AWS Lambda. This one, as I can see from the scroll bar, is going to take a bit. So I think what I'm actually going to do is I'm gonna cut it off here, right? So we did about probably a good hour, hour and a half. I'm not sure how long the final video is going to be with my pauses, but it's definitely been about 2 hours, or yeah, about 6:30. Maybe it's been 2.5 hours. But I think this is a good stopping point. We just finished through that article. I'm super stoked after reading that. I'm really excited about the possibilities there that that article revealed by Levi, and the other articles that we've read as well tonight. So with that, I'm going to cap off part 2 of Jeremy Daly's newsletter for issue number 50. At some point, in the distant future, maybe it'll take a whole week actually to get through all these. At some point, we will get through all these articles. I hope that this context and stuff that's happening, the side conversation that's taking place between me, myself, the camera, and my webcam, obviously, that I keep looking down at, that all this stuff is very helpful to hear about. And I know that personally, I am learning a ton. So I'm already talking about different things. I brought up the Lego.com serverless journey from Sheen Bristles, and I follow him on Twitter and interact with him quite a bit. And having that pop into my head and having this article pop into my head, I think that this is going to be really cool, just in general, right? So I'm starting to formulate my thoughts about serverless a little bit better by talking through it and sharing it. And I think that other people perceiving this information, they think that they're going to get me reading about articles. What they're actually going to get is like a whole full breakdown of like all this other stuff that they're just getting hit with. So anyways, I'll see y'all next time. Thanks so much. Peace.